Hello, I'm audible. Hello.
Yes, you are.
Okay. So, very good evening to everyone. Um, I hope my voice is clear. If it will fluctuate, please let me know. So,
Sure.
today is our first session on week two. So, in this session, we will cover these topics. Okay. So, I'm also having a cold, so let me know if my voice get two words or something. Okay. If you won't able to understand, let me know. So let's wait for 2 more minutes and then we'll start our lecture. So today, first we will cover what is the basic coordinate geometry, which you guys are already familiar with from your high schools, right? That Cartesian plane, what is x coordinate, y coordinate, those kind of stuffs we'll first review. And after that, we will see some of the formulas, that is distance formulas, section formulas, how to compute an area of a triangle if you have a coordinates of three vertices, right? So those things we will cover in the second topic. After that, our main focus will be what will be the equation of line. Okay, so we know that we have a straight line. So geometrical figure is straight line. So if I want to represent or if I want to assign an expression to that straight line, what are the things we need to do or we need to understand? Okay, so those stuff we will discuss. And at the end, we will cover the topic of SSC. SSC is a method to compute an error in any given data with some expression. Okay, so I'll go detail in with SSC too. So that's the overview of our lecture. In between, if you guys have any doubts, you can just unmute yourself and ask. Otherwise, you can just message me in the chat. Okay. Yes, this class is being live streamed, so you guys can find the uh, lecture at the YouTube page, right? Maths One channel is there, so there you can find. It is live stream. Okay. Is there any other doubt? Shall we begin?
Yeah, we can.
Okay. So let's start with basic coordinate geometry. So this is our 2D geometry. So that means we have a plane. So in this plane, if I want to specify the location of any point, so what I'll do? So suppose this is the white paper is our plane. Here is some point P, and I want to tell someone that where this point P is situated. So what I'll do? I'll draw coordinates over this plane. So there are two coordinates. There are two actually axes. One is your x-axis, another one is your y-axis. Okay. So I'll say that these two are my axes and I'll pin a point which is known to be the origin. Okay. So with respect to this coordinate plane, I'll say that the location of point P can be found via two numbers. Okay. So what are those two numbers? So two numbers are x coordinate and y coordinate. This is your x coordinate and this is your y coordinate. Now, what are these two coordinates? So here x coordinates means how much distance you have traveled in your x-axis, right? So that means if you draw a perpendicular from the point P over the x-axis, whatever distance we have traveled here, that is our x distance or x coordinate. So suppose for this point P, I have traveled the 5 distance over here. So that means the x coordinate of point P will be 5. Okay, so another number I'll assign to judge the location of point P in our plane, that is our y coordinate. So as similar to x coordinate, what is the y coordinate? If you draw a perpendicular over the y axis, then whatever distance we have traveled from the origin on the y axis, that will be our y coordinate. Right? So for example, here, suppose I have traveled 3 distance over here. So that means the distance between origin to this particular point, whatever perpendicular we have drawn, is 3 units. Okay, so that means the y coordinate of point P will be 3. Okay, So for here, for point P, we have two coordinates. One is the x coordinate, another one is the y coordinate. X coordinate is just the distance traveled over x-axis. So that means this distance, that will be your x coordinate, and y coordinate means distance traveled over y-axis. So if you draw a perpendicular over the y-axis, whatever distance you have traveled over in the y direction, that will be your y coordinate. So we can assign two coordinates to each and every point. Okay, so this is the basic coordinate geometry. So in between, if you guys feel anything which is not clear or something went wrong, you won't hear my voice or my screen is not visible, just either raise your hand or please unmute yourself and ask. Okay. Feel free to communicate in the class because that's the best way to learn. So now let's go to the next topic. So here we know that okay, I can tell the location of any point in our Cartesian plane, but what about the distance between any 2 points? Okay, so suppose you have 2 points. Suppose this is P, and I have another point over somewhere here, Q. And if someone asks you what is the distance between P and Q, okay, so how can we find that? So for that, we have a distance formula. How we got the distance formula? We just use the help of Pythagoras theorem. We create a right angle triangle over here and then uses the Pythagoras theorem. That's the logic behind the distance formula. You can easily prove how you get the distance formula. Okay. So here we have 2 points, P and Q, and suppose here we have specific numbers, but in general, if you have coordinates, then those coordinates can be written using variables. Okay. So, so what happened in mathematics, whatever unknown quantities are there or whatever abstract quantities are there, so for those quantities, we use some variable. Variable means nothing but a small alphabets, X, Y, Z, W, right? So these small alphabets are used to define a variables. So these are known to be variables. Okay. So what is this variables means? Variable means those quantities which can change situation to situations. For example, in some question you may find the value of x to be 2. In some question you may find the value of x could be anything else, right? So for such type of things, we assign a small letter, small alphabet to that quantity. And it's known to be a variable. It's just a thing in maths that whatever unknown quantity is there, you just assign a variable and then go with that. So suppose in general context, we have a 2 points. So for in general context, I'll say that the coordinate of point P will be x1, y1 and coordinates of point Q will be x2, y2. Okay. So that's we usually do whenever we want to see a general formula in maths, right? We just assign some symbols or some alphabet to unknown quantities and then go with that. So suppose the coordinates of point P is x1, y1 and coordinates of point Q is x2, y2. Then what will be the distance between P and Q? What is the distance PQ? Can anyone recall what is the distance formula?
Under root of x2 minus x1 का whole का square.
Correct. Under the root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is a very basic formula which we have already studied from our high school also, and from week 2 also we revise this. And the proof of this formula just goes like you will form a right angle triangle over here and use Pythagoras theorem. That's the basic logic. That form a right angle triangle, use the Pythagoras theorem, and then you're good to go. Okay. So this is the very basic and first formula in week 2 we have learned. So after this we have a section formula. So section formula, what is this? Section formula, let's see. So suppose you have a line segment P comma Q. So suppose this is your coordinate plane. This is the line segment PQ. And this line segment is actually distributed over two with a ratio m comma n. So suppose this is m and this is n ratio, and a point R is dividing this line segment into the ratio m comma n. And if you want to find out the coordinate of point R with respect to the coordinates of point P and Q, then we will use the section formula. So suppose the coordinates of point P is again x1, y1. The coordinates of point Q is again x2, y2. So suppose this is x2, comma y2. And we want to find out the coordinates of point R. So suppose name them x, comma. And the ratio over here is m, comma n. And we have a section formula which says that the coordinate x coordinate, this is nothing but mx2 plus mnx1 upon m plus n. And the y coordinate is similar for y, that my2 plus ny1 upon m plus n. Okay, so this is the basic section formula which you have to remember. Again, the logic behind this is same thing. You will construct a right angle triangle. here also, here also, and then use the Pythagoras theorem to judge this distance and use the distance formula. Okay, so this is the basic logic. Uh, Again, why we are creating a right angle triangle is because here we get a distance which is parallel to x-axis. So we can compute what is this particular distance is, and similarly we can compute what is the another particular distances, right? So these distances are now known to us because of the coordinates of P and Q. So that's why we use this particular technique. First, construct a right angle triangle, and then use the Pythagoras theorem. Okay, so it's up to your interest. If you want to go see the proof, that's up to you. But mostly questions were asked over the formula. So that means you should remember the formula. What is the section formula is. Okay. I hope that is clear. Now let's move to the next formula, which is finding the area of a triangle using coordinates. So again, the same thing happens over here also. So suppose you have a triangle. Now it's not necessary to be any particular type of triangle. Any triangle with known vertices. Vertices means, so here we have three vertex A, B, C. So you should know the coordinates of each point. The point A, x1, y1. The point x1, y1. The point B, x2, y2. And the coordinate of point C is x3, y3. So suppose you have a triangle on which every vertex coordinates you know, then you can apply this formula to find the area of triangle. Okay, so it says that the area of triangle ABC is actually equal to 1 by 2 modulus of. So here you can remember the cycle. Cycle means suppose first one is x1, then plus x2, and then plus x3. But there is something multiple with this x1, x2, x3. And what are those? So if x1 is there, then y2 minus y3. 2 is there, then y3 minus y1. And if 3 is there, then y1 minus y2. Okay, so 1, 2, 3, 1, 2, 3, that sequence you have to maintain. So like this, you can remember the formula of area of triangle. Okay, so using this formula, you can compute the area of any triangle whose coordinates you know. Okay, so these are the requirements. First of all, you should know what are the values of x1, y1, x2, y2, x3, y3. Okay, so these are the initial three formulas, whatever we have recall in week 2. One is I'll recall again. So the first one is the distance between any 2 points. That is the distance PQ, which is under the root of x2 minus x1, the whole square, plus y2 minus y1, the whole square. Second one is the section formula. Okay, so section formula says x is equals to mx2 plus nx1 upon m plus n, and y is equal to my2 plus ny1 upon m plus n, and the third one is area of triangle. Okay, which we just recall. So this is our area of triangle.
Section formula, there is one more thing, no? Like where you find M and N with the points are given.
So it depends on the question what they are asking. So if they can ask you about what is the value of m and n. That's also you can just change the formula a little bit and you can get your answer.
Okay.
Okay. So in this course, initial 4 to 5 weeks contains the basic mathematics, that is functions, quadratic, polynomial, logarithmic, exponential, and all those things. And in from 6 to 9 weeks, we have covered the whole calculus. This is I am saying to someone who asked in the chat box. So so let's I'll just say that from 1 to 6 weeks, we just have functions, all type of functions, polynomial, exponential, logarithmic, and all those things. From 6 to 9 week, or you can say that 7 to 9 week, we have pure calculus, that is differentiability, limit, and all those things, whatever are required in the basic engineering maths 1 course, right? All calculus tools you need differentiation, integration, right? Basic limit, continuity, those things are there. And in 10 and 11 week, we touched over graph theory too. So this is the basic overview of our course. Okay. So now we are at second week. So initial week we learn about functions. Now we are learning about lines. So in the third week we will learn about parabolas. Fourth week we will learn about polynomials. Okay, so that's how we step by step proceed further. Okay, so let's come back to our theory. So now, so I want to introduce you first of all. What is an expression for any curve. Okay, so suppose here you have a straight line. Suppose this is your straight line. Okay, so in a coordinate plane, this is your x-axis, y-axis. I have a straight line, and I want to clarify this straight line to someone else. Okay, so what I'll do, I'll say that I'll have the straight line. What I'll do, I'll give a relation or give an expression to this straight line. Okay, so what I'll do, I'll create an expression for this line. Expression or equation, you can say. I'll create an equation for this line. So what is that equation refers? This equation actually tell us if there is a point in our plane with coordinate x comma y, then this point is lying on our line or not. Okay, so this is the basic question we need to answer. So the question is, if P is a point, P is a point in our plane, then does this point lies over the line or not? Okay, so this is the question I want to answer. So for this question, what I'll do, I'll create a relation between x and y for a particular line. And that relation is known to be the equation of line. Okay, so that's the basic thing. So if you have a line and you want to give an expression or equation for that line, what is the purpose of that equation? The purpose of that equation is that equation will tell us what are the points which are lying over line and what are those points which are not lying over line. Okay, so that equation will be in terms of x and y. So it will be a relation between x and y. Okay, so let's start with some basic lines. Basic lines means those lines which are parallel to either x-axis or y-axis. Okay, so those lines which are actually parallel to x-axis are known to be horizontal lines. Okay. So this is the first one. I'll come to the topic of slope after this horizontal and vertical line. First, understand what is the equation of horizontal line. What are the equations of vertical lines? Okay. So horizontal line means any line which is parallel to x-axis. So suppose this is your x-axis, this is your y-axis. So this is the line. Suppose this red line cuts the y-axis at the point y is equals to 4. Okay. Now I'll ask you a series of questions. So suppose I have a point over here. This is our point P. Then can you guys tell me what is the y coordinate of this point P?
It will be 4.
It will be 4, correct. Now suppose I have another point Q over here. Now what will be the y coordinate of this point Q?
4.
It will also be the 4.
4, right? So what is the common in these points is no matter what point you will take over this particular line, the y coordinate will be 4 only. Okay. Now if you take another point which does not have y coordinate 4, then does that point lie over this line?
No.
No.
No, right. So that means the only condition for points lying over this line is their y coordinate should be equal to 4. So that means I can say that this is a horizontal line with equation y is equals to 4. Okay. So this is the only statement we need to justify that a point is lying over a line or not, right? So here, is there any specific thing about 4? I can replace this 4 with any unknown quantity, right? Suppose this 4 is, I'll replace that 4 by b. So that means if you have a horizontal line which is intersecting y-axis at y is equals to b, then the equation of that line is nothing but y is equals to b itself. Okay, is that clear? Any doubt?
Clear.
Yeah. Same thing we'll do for vertical lines too. So now the second is vertical. So what are the vertical lines? Vertical lines means those lines which are parallel to y-axis. Suppose this is the line which is intersecting the x-axis at x is equals to 2. Similarly, here also you can find, suppose I have a point P, then the x coordinate of this point P will be 2, right? Because 2 is the distance traveled over x-axis. Similarly, if you take another point Q, again the x coordinate will be 2. So as similar to horizontal line, here what is happening, the x coordinate is not changing. So that means whatever point which has x coordinate 2, that obviously lies over this line. So that means we can say that, okay, the equation of this line is x is equals to 2. But here again there is nothing specific in 2. We can replace that 2 by any number. So let's take in place of 2, let's take a c. So that means if you have a if you have a vertical line which is intersecting x-axis at x is equals to c, then the equation of that line is x is equals to c itself. Okay, is that correct? Any doubt so far? Okay, I hope it's correct. Now, the next topic is slope of a line. Okay, so what does the slope means? Slope means we want to know what are the changes happening in lines. Changes happening in line means we want to know the ratio of change in y upon change in x. So that means if you change x, how much change is the in y is happening and what is that ratio? That ratio is defined to be a slope. Okay, so slope of a line is initially it is denoted by this particular m letter. So usually m is denoted they will denote the slope of a line. So if you have a line, then slope of a line passing through 2 points. So suppose they are passing through point P with x1, y1 coordinates and Q with x2, y2. Then the slope of this line M is actually given by y2 minus y1, which is change in y upon x2 minus x1. It is change in x. Okay, so this is the definition of slope. Slope means change in y upon change in x. Okay, so now let's move back toward the horizontal and vertical line and try to find out what are the slopes over here. Okay, so in the horizontal line, what is happening? If you apply the formula, m is equals to y2 minus y1 upon x2 minus x1. So here what is happening? The y coordinate is not changing, right? B is there, B is there. So that means in horizontal line case, this y2 is always B and y1 is also always B. So that means here the slope will become 0, right? So that means for horizontal lines, so horizontal lines will always have equation y is equals to B. Okay, the slope is actually 0. Okay, now what about vertical lines? Can you guys say something? What will be the
Okay.
slope of vertical lines?
M
It is
is slope.
actually,
It's
yeah,
infinity. It's not
it's
allowed,
actually,
right?
yeah, it's actually not defined. Not
Not
defined.
defined.
We are saying it's not defined because we are not changing x at all. Okay. So in vertical lines, you can see that we are not changing x at all. So slope is actually where slope defines when we are changing in x and we are seeing what will be the change occur in y. But here what is happening? We are not at all changing x, but there is a change in y. So that's why we will say that slope is undefined. Also by the formula, you can see that in the denominator you are getting 0. So whenever we have something upon 0 type of number, it's actually known to be it's actually known to be undefined. Okay. So one more thing I want to clear that here, this 1 by 0 is equals to infinity, we say, right? So this is something which we should avoid. It's actually somewhere not equal to. We are saying that this is something which is very large. Okay. So infinity is not a number. So never treat infinity as a number. It's a symbol which are telling you that this quantity is actually very huge, which we cannot calculate at all. Okay. So always assume that infinity is not a number. It's just a symbol to say that this is something very huge which we cannot write in a finite manner or cannot compute. Okay. So that's why slope for vertical line is actually not defined. Is that clear? Okay. Now, what is the equation of a general line? So for equation of general line, we have several forms. You guys have learned slope intercept form is there, intercept form is there. So all those forms are there. But I'll say that stick to one form. Using one form, using one equation only, you can solve every question. So one of the form is slope intercept form. So this is our equation of line. So suppose you have a line L with slope L with slope M and the y-intercept is, C. Okay, so what is this y-intercept? Y-intercept means that value of y where line and y-axis intersecting. Okay, so that means suppose this is our line, then here this value is actually C. Y is equals to C. So this is known to be y-intercept. So that means that point where where the line intersecting y-axis, it's known to be y-intercept. So suppose I have a line L which has slope M and its y-intercept is C, then the equation of this line is given by y is equals to mx plus C. Okay, so this is known to be a slope intercept form. If you have a slope and if you have a y-intercept, you can find out the equation of line by just substituting the values of M and C. So y is equals to mx plus c. So this is the one of the formulas. Another formula I would say which you should remember is 2-point formula. 2-point formula means Suppose you have a line, suppose L is a line, and the P and Q are the points which are lying over the line. So P with x1, y1 and Q with x2, y2 are 2 points lying over the line L. Then the equation of line L can be written as, can someone tell me what will be the equation? 2-point equation of line. Have you guys remember?
It's a y1, y minus y1
Hmm.
is equal to slope of a line into
Right, which
x
is
minus
y2 y minus y1 into x minus x1. Okay, so this is known to be the equation of line passing through 2 points. So these are the two basic formulas you should remember. First of all is a slope intercept formula, which is y is equals to mx plus c, and another one is this 2-point formula, that is y minus y1 is equals to y2 minus y1 upon x2 minus y1, x2 minus x1 into x minus x1. Okay, you can also generate this particular formula from this one only, but that's your homework. If you want, you can try to generate the below formula from the above formula. Okay, you just have to substitute the value of m and you just have to compute c. Okay, that's all you need to do. So this is the general equation of line, that if you have any line, not horizontal and vertical, because for horizontal vertical we have a specified case, because there okay, horizontal lines you can compute from here, but for vertical lines, since the slope is undefined, we won't use this slope intercept formula. Okay, so these are the things. Now we have one more thing about the slope and lines. So another thing is, see here, what is the slope? So slope m is actually equal to y2 minus y1 upon x2 minus x1. Okay, so if you consider the geometry of a line, suppose this is the line and this is the slope, and suppose you have 2 points here. So this is the point P with x1, y1, and here it is point Q with x2, y2. Okay, now what is this ratio saying to us? What is this ratio is actually equal to? So y2 minus y1 is actually this particular distance. This distance is y2 minus y1, right? And this particular distance is x2 minus x1. And what we are doing, we are taking the ratio of these two distances. So from the trigonometry, you know that if this angle is theta, then what will be tan theta? So tan theta is nothing but y2 minus y1 upon x2 minus x1. But this particular angle theta is similar to the angle formed by the line and the x-axis, right? Because we know that if a line cuts if two parallel lines cut right, these things, I hope you guys remember. So suppose two parallel lines are there, and if one line intersect these two parallel lines, then whatever angles are formed, these angles are equal. Suppose this angle will be equal to this angle will be equal to this particular angle, this angle will be equal to this angle, and same thing for this one, right? So this is the geometrical form. So here also what is happening, this is a line, this red one, these two lines are parallel, and this particular equation, this particular line L is intersecting two parallel lines. So whatever angle formed here, this angle and this angle will be same. Okay, so that means here theta is an angle which is formed with our given line L and x-axis. So using this angle theta also, we can judge what is our slope is. So this to sum up the whole theory is that if theta is an angle between the line and the x-axis, then the slope of a line m can be written as tan of theta. Okay, so this is also another important thing about slope of a line. So if theta is an angle, then the slope is also written as tan theta. Okay, so now with respect to slope, we can judge some of the things. Okay, so one thing is, suppose you have two perpendicular lines. Perpendicular lines means they are intersecting at 90-degree angle. So suppose here we have two perpendicular lines. One is this, and another one is this. So these are two perpendicular lines, 90-degree angle. This is L1 and this is L2. Okay, sorry. So now what we want to understand, if we have a two perpendicular lines, then what will be the relation among their slopes? Okay, so can you guys recall what will be the relation among their slopes? if m1 is the slope of line L1 and m2 is the slope of line L2, what is the relation between m1 and m2?
M2 into M1 is equal to minus.
Correct. So actually the relation is if you multiply both slopes m1, m2, that's equal to minus 1. Right? So this is the
Basically,
relation. Yeah. Is there any doubt?
I'm saying it's basically the inverse relation between both slopes.
Correct, correct. Because what is happening here? So suppose this angle is theta, then this angle will be 90 plus theta. Right? So that means if m1 is equals to 10 theta, then m2 will be is equals to 10 of 90 plus theta. But we know that 10 of 90 plus theta is nothing but minus of cot theta.
Cot.
Right? So that means m2 is minus of cot theta. That means m2 is minus of 1 by 10 theta. And what is 10 theta? 10 theta is m1 itself. So m2 is equals to minus 1 by m1. So that's why we are getting m1 into m2 is equals to minus 1. Okay, it's a simple proof. So the reason behind this is, if one angle is theta, another angle will be 90 plus theta. And the 10 90 plus theta is nothing but minus of cot theta. So this is same. So if you have two lines which are intersecting at 90-degree angle, then the relation between their slope is m1 into m2 is equals to minus 1. Okay. Now same thing we can judge for parallel lines too. So for parallel lines, it's kind of easy. You can easily find out. So suppose this is a line L1 and this is another line L2, and suppose they are parallel. Then what will be the relation among the slope?
M1 equals to M2.
Correct. M1 is equals to M2. Because I initially just told that if you have two parallel lines and if another line intersecting these two parallel lines, then whatever angle, corresponding angles are equal. Okay, so this is the fact. So here two parallel lines is there and this is the x-axis which is intersecting two parallel lines. So whatever angles are there, corresponding angles will be equal. So that means if this angle is theta, then this angle will also be theta. So that is the value of M1 is tan theta. The value of M2 is also tan theta. So that's why they are equal. So if you have a two parallel line, then the slope of two parallel lines are actually equal. Okay. And then we have another formula to find out the angle between two lines. So this is angle between two lines. So this angle between two lines we can compute using the slope. So it says that suppose that theta or yeah. So suppose that in place of theta, let's use phi. So suppose phi is the angle between the lines L1 and L2. What is happening? What angle we are considering? We are considering this particular. Okay, so suppose we have these two lines L1 and L2. Then what will be the angle between them? So that means what will be the angle this particular phi is. Okay, so this angle we want to find out. For this one, it's actually we have a compact formula which says that tan of phi is actually equal to m1 minus m2 upon 1 plus m1 into m2. So this also you can derive from using the same logic that tan theta is there. So it's a simple proof of you have to use this particular formula tan of a plus b. Then you can compute. But you should remember the formula for finding out the angle between any two lines. Okay, the tan of phi is actually equal to m1 minus m2 upon 1 plus m1 into m2. Okay. So now the last formula of equation of line is if you have two parallel lines, then how you can compute the distance between two parallel lines. Okay. So that means suppose you have these two lines. Suppose you have a line L1 whose expression is given by ax plus by is equals to c1 and another line L2 whose expression is given by ax plus by is equals to c2. So what happens if you have a parallel lines, then the parallel lines only differ at the constant terms, that's c1 and c2. So here you can find out the distance between two parallel lines is actually. So this distance, for this particular distance also we have a formula which is modulus of c1 minus c2 upon under the root of a square plus b square. Okay, so this is the last formula for v. It says which compute the distance between any two parallel. Okay. So yes, this is a very basic geometrical structure that in this particular week we understand what is actually line represents, what are the different variables are there, what are the different things are there about the equation of line and all those things. Okay. Is there any doubt so far, whatever we have talked? I think it's just the high school stuff, but it's a good recall. Any doubt so far?
No, ma'am.
Okay, cool. So now let's go to the next topic, which is SSE. Okay. So what is this SSE is? So see, SSE means it's just a method to find out the what you can say error between your data and your expression. Okay, so what does that mean? So it's squared sum error, right? Yes. I'll also explain what is this name stand for. Okay. So SSE means squared sum error. So we'll come back to name too. So understand first of all what is happening over here is, so suppose you have a situation, suppose you are at some lab and you are doing some practical, and in that practical you have a temperature and another thing is the heat. So as you increase your temperature, your heat also increases. Okay, so this relation we know. But what happened? We can compute the heat with respect to temperature up to only finite things. Okay, so what happened if you have an expression for that, then the computation will become very easy. Okay, so suppose you have another example I can take. Suppose uh, one variable is, so suppose you have one thing is, which is your money. Okay, you have some amount to invest in into something, and another thing is investment, or you can say that investment and return will be better. Okay, so here you have investment and here is your return. Okay, so suppose you have invested some money. So suppose you have invested 1 lakh and you will get return in 1.5 lakh. Another year you have invested 2 lakhs and you got return again 1.5. Another year, so suppose this is the story of first year, second year, third year. In the third year, what happened? You invested, okay, see, let's try to invest more and more money. So suppose you invested 4 lakhs and you get the return of only 2 lakhs. In after that, another year, you are seeing that, okay, I'm getting in the loss. So you invested 0.5 lakh and you will get the return of 1 lakh. Okay, so here what is happening? This return is somewhat dependent on your investment, but we don't know how it is going to behave in the future, right? So if you want to predict what is your future is with respect to the investment and return, what you will do, you'll try to relate the return with respect to your investment, right? You'll try to relate this one with respect to this one. Okay, so what we are doing, we want to find a relation between one variable and another variable, and if we are able to find the exact relation, then we can predict the future, right? Then we can just substitute the, suppose if I say that the equation y is equals to 3x plus 4 is justifying this particular return and investment behavior. So that means if you invest x amount of money, you will get y amount of return. Okay, so suppose someone says that, okay, this is the formula for this investment and return. And what you can do that, okay, so now I can just substitute the value of x here and I can tell what will be the return I'll get next year or any other time, right? So that means if you have an expression which justify your data points, then you can easily predict the futures, or you can easily predict what are the other what will be the next value I can get, or what are the inputs I need to substitute for getting maximum return or minimum return and all those things, right? So here what does this square sum error do? It actually find out the gap between your expression and your data point. So that means whatever expression you are giving to your data set, that expression is validating your data or not, or how much error is there in between your data point and expression. Okay, so this error is actually computed by squared sum error. Okay, there are actually kind of so many errors you can actually compute between the data and an expression. So suppose you have some data points over here, some x values are here, some y values are here, and with this data point you have an expression. Okay, in our case we are just saying equation of line, but in general it could be anything. But since in our course we have gone through only lines only, that's why I'm writing y is equals to mx plus c. Okay, but here it could be any function. So suppose you have one data set and you are saying that this expression is justifying this particular data set. Now what I want to do, I want to compute the error in between these two things, right? That what is the actual data is and what is this particular expression will give us, right? Because if there is any other value x naught, then for this particular x naught there is a quantity in our table, and for this particular x naught I'm also getting some y naught over here too, right? Or if you say f of x, then f of x naught, right? So what is happening, for a point x naught we are getting two types of thing. One is which is listed over data points, which is listed in our table. Another one is we are getting from the expression. Now square sum error actually tell us what is the what is the error between these two things. Okay, so what this is say that the error square sum error is actually equal to, what you will do, you will first of all you will find the difference, that is the original value minus f of xi, and then square it and then sum it. Okay, so that's the particular formula. So suppose you have suppose I'll take some finite numbers. So suppose I have 5 points x0, x1, x2, x3, x4, and with respect to this I have y0, y1, y2, y3, y4. Okay, and this is your f of x. Then square sum error says first of all the original value y0 minus the whatever value you are getting from your expression. First compute the distance and then square it, and then sum with another quantities, because we have here 5 points, right? So y0 minus f of x0 the whole square, y1 minus f of x1 the whole square, plus y2 minus f of x2 the whole square, plus and so on up to last point, which is y4 minus f of x4 the whole square. And in place of f of x0 you can write mx0 plus c, right? Just a computation. So here this is one method. This is one method to find an error between the dataset and the expression. There are another method is, you guys may have learned what is a relative error, what is the absolute error, right? Those types of errors are also there. So that means there are different methods to compute errors, and this square sum method is one of the method to compute an error between the dataset and the given expression. Okay, is that clear? Have you guys got what is actual this SSC means?
Shouldn't we take the square root at the end?
No, we haven't take the square. We won't take square root. It's just the squares.
Okay.
Is there any other doubt? I'm not hearing you properly.
No, I understand that you're squaring it so that it doesn't cancel out, no? Some would be
Yeah, so
above,
won't
some
we
would
get
be
negative
below,
values? Yeah,
so
that's
that you know. But uh, um, uh, just like the other gentleman was saying, should
hmm.
if you square rooted the whole thing, it would kind of make sense, right? I mean, it would kind of bring the value down to something we can perceive.
Yeah, that's also true, but it's okay. It's just an error. So if you find out the square root of that error, that's also okay.
Oh,
Or
okay,
else
okay.
we want a positive quantity. So that's the
So,
only thing.
okay, okay. So eventually, how do you figure out if the values are like really off or whether they are okay?
Yeah. So see, here if the distance between these two things, y0 and f of x0 are very less, then we can say that okay, this expression is going a little closer to my data set, right? So that means these quantities should be less. So ultimately we say that if SSC, the value of SSC is minimum, then that expression is the best fit for our data set. Okay. So this is also another thing which is the best fit. So we say that an expression, whatever function you have, is the best fit for whatever given data set if the SSC is minimum, if the value of SSC is minimum. Because it's kind of obvious that if you made if you made a little error, then that will be a better thing. So if the value of SSC is less, then that means that expression is somewhat closer to our data set, right? Okay, so if you solve one or two questions over SSC, you will get more and more ideas So there are plenty of questions over SSC in I guess AQPQs.
Ma'am, can you explain this through an example?
Okay, so currently I don't have an example, but yeah, I'll see how. So one basic example is you just have a data set and you have an expression, compute the SSC, that type of questions you can take. So suppose here you have, let me find one precise example of SSC. Just give me a second. Okay, so I have one question. So in this question, what is happening? Let me state the question over here. So here a fitness trainer is there, which is analyzing the weight loss progress of his best clients over the period of 6 months. So that means there are 6 months, and he's kind of experimenting the weight loss of a particular client. Okay, so this is the data set we have. So here is the month 0, and the weight is 98, and similarly 1, 2, 3, 4, 5, 6. And the amount is 90, 90, 82, 74, 66, 57, and 49. So yeah, we can identify that. Okay, so this is the data point you have. So that means there was a fitness trainer which is analyzing the weight loss of a client over the period of 6 months, and this is the data he has. And what he wants to do, he come up with an equation of equation is like W is equals to minus of 8t plus of 98, where obviously W represents the weight and T represents the month, whatever month you are in. So this is the expression that particular trainer come up. Right now, he want to analyze that this expression best suited for our data set or not, and he give a restriction that okay, any expression is best suited if the value of SSC is less than 5. If the value of SSC is less than 5, so that means whatever expression you are using to analyzing the weight change over the time, that expression is best fitted. Okay, so if SSC is less than 5, then the expression is well fitted or best fitted, whatever word you want to use, you can use. Okay, so this is the condition. Now the question asked here is, does this expression is a best fit or not?
Less than 5. Actually, when you understand us SSC, there's some network issue. I can't
Oh.
hear that part.
Okay, so actually what is happening, SSC is just a method to calculate an error between the given expression and the data point. If the value of error is less, that means that the expression is justifying our data set. If the value of error is bigger, so that means that expression is not that well fitted or best fitted. So here the question is, there was a fitness coach which want to analyze the weight loss of any of his client. So he just recorded the data of 6 months, and over this particular data, he said that if any expression which has SSC less than 5, that expression will say to be best fitted for our data set. Okay, so this is the condition given. Now the question says that this particular expression W is equals to minus 8t plus 98 is best fitted or not. So what you have to do, you have to find out first SSC, and if the SSC is less than 5, then that means yes, it is best fitted. If the SSC is greater than 5,
What is the
then it's not.
formula to find SSC?
Yeah, so formula to find SSC is, see, these are the values of y. So that means this is your y1, this is your y2, y3, y4, y5, y6, and y7, right? And these are the values of x, x1, x2, x3, right? So what you have to do, this is one value you have given, and another value you can compute by the this given particular expression also, right? So that means first one says that 98 minus this w of 0. Okay, so w of t is minus 8t plus 98. So what will be w of 0? W of 0 will be 98 only. So this 98 minus 98 will be. Okay. So let's write it down first, and then we'll check what is SSC. So here SSC will be, first of all, initial value, which is y1. So initial value is 98 here. So this is the first value, 98. Now 98 minus w of 0. Okay. So see, what are the things are given to us? One data set is given to us, one expression is given to us. So that means we have to use both of them. So from the data set, you will collect the values of y1, y2, y3, y4, y5 up to y7. And from the expression, you will compute the value of w's on these x points, right? W of 0, w of 1, w of 3, and so on. And then square it and sum it. Okay. So plus with again 90 minus w of square it. Then plus another one is 82 minus w of 2 square plus 74 minus w of 3 square, then plus 66 minus w of 4 square, then plus 57 minus w of 5 square, right? And then plus last one is 57 is there, 49 minus w of 6 whole square. Okay, now this will be your formula for SSC for this particular question. In general, whatever a function is there, it replace that function and with the points. Okay, is that clear so far? What I'm
Yes.
doing? Okay.
Yes, ma'am.
Now this substitute the values. So what is the w of 0? W of 0 is 98. Right? If you substitute t is equals to 0 over here, minus 8 into 0 will be 0 and the 98 will be. If you substitute 1, then what will be w of 1? It will be 90. Right? Because minus 8 plus 98 will be 90. What is w of 2? So minus 8 into 2. So see, minus 8 into 2 plus 98. So that means minus 16 plus 98. So that will be equals to 82. Right? 6, 8 minus 6 and 1. So 82. This is also 82. What is w of 3? So w of 3 will be minus 24. Yeah, plus 98. So that will be 74. W of 4 will be minus 32 plus 98. So that will be 6 and 666. W of 5 will be minus 40 plus 98. That will be 58. And here W of 6 will be 48 minus 48 plus 98. And that will be equal to 50. Right. So here see, from this bracket we are getting 0. From this one also we are getting 0. From this one also 0. From this one also 0. Here also 0. Here we are getting 1 and here we are getting 1. So that means here the SSC is actually equal to all 0 plus 0 plus 1 plus 1. Right. So only last two brackets are giving us 1. So that means here the value of SSC is 2. Right. Which is less than 5. So the answer is yes. Yes, we can say that this particular whatever expression he has come up with, it's a best fit or good fit for our data set. Okay, so this is the basic type of question asked for SSC. There are another type of question where you want to find out the constants, but I want you guys to try first by yourself and then we can discuss it. Okay, is that clear?
Yes, ma'am.
Okay, fine. So have you guys gone through the video lectures yet?
No, ma'am. Week of week 2 and
Okay. Hmm. Okay, fine. So that means you haven't solved the EQ PQs, right? So if there is any doubt from AQ PQ, we can discuss it now, because that's all from theory. There is nothing more in theory from week 2, just basic equation of lines, some of the formulas, and last one is SSC. But SSC is something which if you practice more, then you will understand more type of thing, right? Because SSC is just a formula to compute an error. Basic thing is you have a data point. Okay, see, you have a data set, you have an expression, and what is the error this expression is giving to us with respect to data sign. That is the thing SSC will tell us. So SSC is just a formula to compute an error. Okay, nothing else. So there are 2 to 3 types of questions based on SSC. One is very simple type of question which we have solved here. Another one is where you need to find out, you need to figure out from 2 to 3 expressions. So here only one expression was there, but in place of one there could be more than one expression, and you have to judge from those expressions which of them are best fit, right? So the thing is, again, the minimum SSC will give us the best fitted answer. So you just have to find out an expression with minimum SSC. Okay, so that will be second type of question. Yes.
Ma'am, in some questions, like slope is not given. There are minus it is slope, but there is a 1% in practice assignment. The slope is not given. They are asking when can be minimum SSC.
Okay,
What
so can
value
you
of
paste
slope?
that
They are
question in chat box? That will be better. Just take a screenshot and paste that question in the chat box.
asking.
Because I'm not able to listen you, and also if you verbally tell, it's possible to do a mistake. That will be easy. Yeah, so that's all from my side. If you guys have any doubts, then we can discuss over here.
Ma'am, we check
Yes. What? Yes. So here, what is happening? A new detective agency come up with a relation H is equals to MF plus 70, where H is the height of a male adult and F is the length of femur bone. They have used the following sample set given in the table such that the sum square error is minimum. Okay. So what you have to do for these value of M, you need to calculate SSC. So see, what you need to do. So here, the question is pasted on the chat box. You guys can look at that question. So here the expression is given. The expression is given H is equals to MF plus 70. And one data set is there. Okay, so this data set is 150 and then 40 here, 160, 170 and 180. 160, 170, 180, 40, 42, 48, 46, 56. Okay, so this is the data set and this is the expression is given to you. And the question is for which value of m, for which m, and there are 4 options are given to you. M is equals to 1, m is equals to 1.5, m is equals to 2, and m is equals to 2.5. So for which option the SSC is minimum? SSC is minimum. This is the thing you need to calculate. So what you will do, first of all, fix the value of m. So here first I'll take m is equals to 1. So if you took m is equals to 1, then h is equals to f plus 70. Right? Just substitute the value of m over here. The expression will become h is equals to f plus 70. And these are the values of h is given, and these are the values of f is given in the question, right? So here you can calculate SSC for m is equals to 1. So what will be your SSC? SSC will be again the whatever value is here 150 minus f plus 70. So 40 plus 70, that will be 110, the square. Then plus 160 minus 42 plus 70. 42 plus 70 will become 112, the whole square. Then plus 170 minus 48 plus 70, that will be 118, the whole square. And then plus 180 and minus with f plus 70. So the value of f you will take 56. 56 plus 70 will be 126, the whole square. And you can calculate some number over here. Okay. So this is for m is equals to 1. Same thing you have to do for m is equals to 1.5, m is equals to 2, m is equals to 2.5. And then find out what will be the value of SSC. Okay. So from the pattern, can you guys just guess what will be the value of m for which we will get the minimum SSC? Can someone guess what will be the value of m?
Ma'am, 1.
2. 2.
We want minimum SSC, not maximum SSC. Minimum SSC will give us the best rate.
Yeah, it is 2.
Sure for 2. What about 2.5?
No, I think it's 2. Because I'll tell you how I am going by this.
Mm-hmm.
I'm just subtracting 70 from all the h values that's given.
Correct.
Okay,
Yeah,
so
that will be
it will
good
give
approach.
you, yeah, so it will give you 80, 90, 100, 110.
Right. 80, 90,
And
100, 110.
yeah, the closest that's coming is 2 times of f. So it
Correct.
should be 2.
Yes, correct. Because see, now you just have to 2 multiple of these quantities. So that will be 80, then will be 84, right? This will be 96, and this will be 112, right? So if you substitute 2, these values you will get. If you substitute 2.5, I think you will go a little further. So that's why m is equals to 2 will give us the minimum SSC. Okay, so this is also a simple kind of question. Ultimately, you just have to use the formula and find out the SSC. There is nothing logical you have to do, right? Just fix m is equals to 1, find SSC. Fix m is equals to 2, find SSC. M is equals to 3, find, sorry, m is equals to 2.5, and then find SSC. You'll get your answer. Okay, is that clear? Any doubt? Any other doubt?
So we need to check from option.
Yeah, we need to check from option. That's correct. Okay.
Actually, you won't get time to actually do all the 4 things in exam. You should figure out like how I actually interpret it.
Yeah, it's actually up to your practice. See here, the only 4 points are there, right? So calculation won't take more than 2 minutes, I guess. And 4 points are also easy, just 70, right? Okay. Fine. Anything else which is not clear? Okay, so see, Maths 1 course will go a little slow in initial steps. So that means week 1, week 2, week 3. Up to week 3, you will feel like, okay, it's very lightweighted, but it will get tense when you start the calculus part. So I'll suggest up to, see, from quiz 1 to 6, you should be well prepared. So that means this thing, you should be very good at these things so that because you won't get time after quiz 1 to revise all these contents. Okay. So from quiz 2, when we started calculus, it will become very hectic, and there we actually don't get that much time to explain every concept. Okay, so initial 6 weeks are very easy. It's very lightweighted, but after that you need to spend some more time over this course. Okay, so I'll suggest just wrap up these 6 weeks as quickly as you can. And if you are someone which is already familiar with this 6 week content, you can go to YouTube and watch the other week's videos also, right? Because calculus part is a little bit tough, and there we get only 3 weeks to cover that things, which is a little less. Okay, so if you think that these things are very basic to you, equation of lines, equation of parabola, and all those things, you can just invest your time into something else, right? But first, solve all the questions, AQ, PQs, GAs. If you are done with all those things, then only move to the next topic. Okay. Fine, then that's all from my side. If you guys have anything to discuss, we can discuss. Otherwise, we can wrap up our session over here. Okay. Okay, then if you guys don't have any doubt, yes. Thank you guys for joining.
Thanks a
Ma'am,
lot.
ma'am,
Yes, who's there? Yeah.
ma'am, can I ask a doubt? Not from this lecture.
Mm-hmm.
Ma'am, actually, I received a mail in which it's written that your house allocation details and it given a PDF. Ma'am, what is meaning of house allocation details?
House allocation. That
Yes,
actually I also don't know. I'll ask someone and let you know in the next session. House allocation is there, na?
yes, ma'am. Actually, the mail has received from studentaffair@study.iitm.ac.in.
Okay.
Ma'am, is it reliable?
Uh, what is the last domain? iitm.ac.in is there.
Yes, ma'am. iitm.ac.in.
Yeah, so if it's coming from IITM domain, then it's reliable. But don't follow that. Just ask someone over the support team. Okay, I'll also ask house.
There are actually 10 houses in the IITBS course.
Okay,
The
okay.
Narmada, Wayanad, and like Gil. So there are all actually 10 houses, and you have been assigned to one house out of the 10, and that house will actually like take care of like all the activities you have in the as you go along. No, there's no there's no offline presence. There will be
Mhm.
your online presence for solving, and you can make friends and all that. So
Okay.
that's why
Okay.
it's a
Mhm. Yeah, I don't know about this stuff, but you guys can talk to each other and see if.
So when will be solving the sums, Samiksha? Like,
Problems.
yeah, problems.
Yeah, in the next session we'll do start with
Okay,
solve with us, and then I'll take some doubts.
Ma'am,
cool. Thank you.
Yes.
ma'am, in Solve with Us, would it be possible to do all the activities?
No, all the activities, all the practice assignment won't be possible. One reason is there are too many, and the uh, second reason is we are here to take your doubts. So if you have already done those things and you're having some doubts, then I can solve that question. Not entirely solve. I'll also take your help that what you guys are thinking, how you approach that question, because that's the purpose. If we solve, then there is nothing to do for you guys, right? So that's the thing that we first thing is we obviously cannot solve each and every question within 2 hours of time period. And second thing is it's not there for me to do it, right? It's there for you guys to have practice and solve some of the questions. Okay.
Okay, ma'am. Thank you, ma'am.
Okay. Okay, then see you guys in the next session. It's on Saturday. So see you then.
Thank you.
Yeah, good night. Bye.